Right, we'll now learn about increment and decrement operators. We will use them quite a bit once we get into looping structures. You'll find they're handy to quickly add one to a number or subtract one from a number. So the increment operator is plus plus, no spaces in between. It has two forms, prefix and postfix. So you can either write plus plus x or x plus plus, but they have different side effects of when they change x's memory. Now the operand data type may be integer or floating point, and all it does is adds one to the value stored in that variable. So it does affect that variable's memory. So postfix increment operator x plus plus. So postfix means the plus signs come after the x, and it actually changes x's memory after it goes out and fetches its value. So order of operations. X plus plus, we're going to say that we've got 4 stored in x. Right? When the statement x plus plus executes, it goes out and gets the data value or fetches x's data value. Right? So it goes to the memory. In this case, it would go to memory and return the number 4. It then will, it may be discarded, it may be used, depending on how we write it in code. But what it does after that is it changes x's memory by adding 1 to it. So let's just look at its effect in a printf statement. Well, we've got this program where x is set equal to 4. Right, we're going to print out then this text value of expression xx is %d. Out here, x plus plus, the way the postfix works, right, post meaning the plus has come after, is it goes to memory and fetches the value that's there, 4. So we're going to see this expression evaluates to a 4. It will substitute a 4 in here. Now on the next line, when we just go ahead and want to print what's stored in x, well, we'll see that x has changed from 4 to 5. It's added 1 to it after it returns the value from memory. So fetch the value, then add 1. Post means after. The plus signs come after. Fetch the value, then add 1. And usually got same example in code blocks, right, if we want to run it real time. We see that we get a value of 4 here, and then x has been changed to 5. Same as the example. Now, let's change this to prefix. So prefix, right, means the plus signs come before the x. So prefix means do the addition first, add 1 to x, and then return its value. So we're going to see then that it's going to add 1 to x. This expression will evaluate to a 5, and this expression will evaluate to a 5 as well. So they both evaluated a 5. So postfix, return what's in memory, then add 1. Prefix, add 1, then return what's in memory. So those are just the same examples there. There's a summary of the difference between prefix and postfix. All right, let's take a look at the decrement operator. So decrement usually means subtract, or usually it does mean subtract 1. It can have a prefix form and a postfix. Remember the word pre means before. The negative signs, the double negative sign comes before the x. Postfix, post means after. The 2 signs mean after. This means subtract before you return the value of memory. This means subtract after you return the value of memory. Notice that it has a side effect of changing x's memory, right? The same way as the increment operator. And again, the data type may be any integer or floating point type. Just get it. In this one, right, we've got x equal 4, same example, x minus minus. This is go to memory. Postfix says return what's in memory. It's going to return the 4. Then it's going to subtract 1, and then we'll see that the new value here is 3. If we run this. And then pre means subtract the operand before fetching the value from memory. So x starts out at 4 again. Pre means subtract first. So subtract 1, x becomes 3. Return the value in memory 3. And then when this prints out, we can see X is still 3. Right? So pre means perform the operation before you return it from memory. Post means perform the operation after you return the value from memory. Right? Like I said, we'll find these very handy. And finally then, here's a precedence chart of the different operators that we have discussed. Parentheses and increment and decrement, all the same level of precedence. They're the highest level of precedence. Right? Postfix, so postfix, increment, decrement. Then next, prefix, increment, decrement, unary, plus and minus, these are all the same level. These associate from left to right. That makes sense because postfix, right, simply means return the value memory, then do this after. So the value memory is the variable on the left, like x plus plus. Right? Multiplicative, right, here is my multiplication, division, and modulus, right, left to right. Addition, next level of precedence, and assignment, along with all the compound assignment operators. So assignment is always the lowest in the table above. You might find this table handy to print out for when you're working with your mathematical expressions. And then finally, there's one last category in C called do-nothing expressions. A do-nothing expression does exactly that. It does nothing. It is a legal statement. So the null statement, just a semicolon in code, is a legal statement. It performs no actions. Basically, it's a placeholder. And then in the early days of computing, they used to try and use it to actually slow down a program because it was called a no operation statement, but it actually took up a clock cycle, right? If you take up some clock cycles, you can slow down the computer, right? Take up CPU cycles. We'll see in the future that we'll have some statements, so that's what this warning is about. We'll have some places where we don't put a semicolon, and if we put one there, it actually gives us problems. It'll act as a no operation statement. So what you want to pay attention to is sometimes you mistype something in a program. So if you get a warning, right? If you type something like x times y in a program, and you're not doing anything to change memory, you're going to get a warning about a statement with no effect. Same way if you just type a semicolon all by itself, you might get a warning about a statement with no effect. Your compiler will likely optimize these away, but you don't want to leave any of these things in. And you don't want to ignore those warnings, right? Because you might mean to type. So in this example, suppose you meant to type into a program sum equals 12, but you accidentally typed sum minus 12. So in this example, here's our program. We've got this variable named sum. Suppose we meant to initialize, we meant to assign the value of 12 to sum, but we accidentally typed the sum minus 12 sign. Well, then we would get this warning that said statement with no effect. Right? And at that point, we want to go back and look at the program and say, did we really mean to type that? Chances are no, and we'll make a correction. Another reason we don't want to ignore our warnings. Our code runs with warnings, but it doesn't do what we expect all the time. Right. Yeah, that is the end of this lecture.